All right, it's a pleasure to introduce our guest speaker today. Kent Rominger comes to us from Orbital ATK, a global leader in aerospace and defense technologies. One of Utah's premier contributions to the American space landscape, Orbital ATK has a deep legacy, from providing spaceflight hardware for the former space shuttle program to continued contributions to the changing spaceflight landscape. As Vice President of Strategy and Business Development for the Orbital ATK Propulsion Systems Division, Kent plays a central role. His experience in spaceflight and aerospace technology is deep, having flown as a NASA astronaut 5 space shuttle missions, including 2 as mission commander, and having led the NASA Astronaut Office as its chief. In addition, he served over 25 years as a Navy fighter pilot and test pilot, both in and out of the wartime theaters. He has a degree in civil engineering from Colorado State University and a master's degree in aeronautical engineering from the U.S. Naval Postgraduate School. He's very active in community efforts involving STEM education for all age groups. He's currently the chairman of the board for Challenger Learning Center, and here in the Valley is a member of the Clark Planetarium Board of Directors, where I met him for the first time several years ago. He's active in civil aviation and is a member of the NASA Astronaut Hall of Fame. He's an avid snow and water skier and loves all things loud and fast. It's my pleasure to introduce our speaker, Kent Rominger.
Hey, well, thank you all for coming out today. What I want to share with you are my experiences when I was with NASA as an astronaut. And hey, by the way, how many in here think that it would be fun to be an astronaut? Great. You and I are a lot alike then. How many in here like acceleration and speed and things that go fast? And all right, this is going to be fun. Because the fact is, I think the reason I became an astronaut was because of a genetic defect. And there was a study done, matter of fact, a long time ago when I was in college, when I'm where you are, I found an article, what do thrill seekers have in common? So I thought, man, I might read this article. And it talked about skydiving, hang gliding, racing motocross, scuba diving was in there, which was interesting to me. But as I started to read kind of how they were classifying thrill seekers, you know, I thought, hey, I do all that stuff. So I kept reading, and what they had determined that was the one thing in common amongst all of these, their sample group, was they were either completely missing or had a very low quantity of a certain enzyme. And I don't remember what enzyme that was, but I thought, hey, I obviously have an enzyme deficiency because I love acceleration. So what I've got are some PowerPoint slides, and then I've got a couple of home videos. They're just a couple of minutes each to take us through a space shuttle launch, and then the other end of it, the entry and landing of the space shuttle. Please think of questions. I'm going to try to get through everything I've got here in 40 minutes or less. I'd love to save 20 minutes. So a third of this time is dedicated to you and questions. And for me, the question and answer period is the most fun of it, most fun part. So please think of questions. You can't ask me a question too hard. Well, you probably can, and I'll just say I don't know. But don't restrain yourself from asking any questions. So with that, hey, can you all see that, or should we dim the lights? Sorry for our guy doing the streaming. That's kind of what I thought. So anyway, math and science, I'm a big believer in STEM education. My mother was an English teacher, and so when I went to college, the one thing that I loved about majoring in engineering at Colorado State back a long, long time ago was it was the only major on the campus where you did not have to take speech. And so that was a big incentive for me to go into engineering. Since then, I've learned communication skills are very valuable. So the STEM, you know, the math and sciences are important. So are communication skills, very important. My passion is flying. From the time I was 5 and got to fly with my father, I wanted to become a pilot. And in college, I wanted to be an airline pilot. And I'd love to have been an astronaut. The truth is, I grew up in a small town of about 1,400 people in very rural Colorado. I didn't think it was a realistic goal, so I never set that goal for myself. And said, well, hey, I want to be a pilot. I'll be an airline pilot. Talked to the airlines, and they said, well, hey, the easiest way to get the experience you need is to join the military. I didn't want to join the military, so I put that off as long as possible. But then when I did, after I made it through college, I absolutely loved it. Wound up flying F-14s in the Navy. And this was on an aircraft carrier. It's a flyby. And although the guy in the front seat of this airplane was having a lot of fun right here, I'm glad it wasn't me, because he got to not fly for a few days after doing this. The air boss on the ship was not as impressed as those of us standing on the flight deck were. But I mentioned it earlier, but I love acceleration. And the fact is, even today, I've never been on or in anything yet that's had enough acceleration. So the trusty Tomcat that we saw here, when I was a test pilot in the Navy, we wound up putting bigger engines in it. My timing was great. My timing was such that the very first one that Grumman Aerospace put the bigger engines in came to me, and I was the pilot to qualify it on the aircraft carrier. And so it was a lot of fun, a lot of great flying. These engines had so much more thrust. It was literally a rocket ship, but it still could have used more. So then we would go to the space shuttle. You're looking at 7 million pounds of thrust here, which is good. It's actually great, but still could use more acceleration. In one of the questions you may be asking, sadly, we retired the space shuttles in 2011, but I was at NASA from 1992 until 2006, and particularly the last 15 years of that period. We almost exclusively used the space shuttle for building space station. And it was a phenomenal machine. Here is space station. There are 6 astronauts on board today, actually a combination of astronauts and cosmonauts. And there is a huge amount of mass that's in orbit when you look at all of these modules and all the solar arrays and the radiators. I'd say 85% of all that mass went up on the space shuttle. So it really was a great time to be a space shuttle astronaut. We were literally a construction crew, hauling equipment up to space station, assembling space station. But one of the neat things I got to do along my journey was the first mission where I was assigned as mission commander. I went to space station when it was this big. So this is one piece, the very first piece of space station, International Space Station, and this launched in December of 1998. Actually, I lied. It launched in November of 1998. Does anybody know where this piece of space station came from? It was launched out of Russia. It was a Russian build. It actually launched out of Baikonur Cosmodrome in Kazakhstan on an unmanned rocket. And then in December, a month later, on the space shuttle, we launched the second piece of that space station on a space shuttle. It took it up in the payload bay. And the payload bay on the space shuttle is huge. It's 15 feet wide, 60 feet long. And to put that in perspective, you know, these large buses that you charter would easily fit in the payload bay of the space shuttle. And the space shuttle can haul that much payload. It can easily haul 40,000 pounds of payload into orbit. So you literally could grab one of these buses rolling down the road, stick it in the payload bay, and it has the capability to lift that much mass and the volume to lift that much into orbit. So after that space shuttle went to space station, it docked, it actually grappled the Russian-built piece and assembled on the piece that came out of the U.S. And that piece was called a node, because it really was just like that, a Tinker Toy node where you use it and it supports the continuous assembling station. And now if you think back a couple pictures where you saw that huge space station, this is how it all started. And then the next flight that went to space station was one I was fortunate enough to be on. And it was a really exciting flight. We were the first shuttle to actually dock with that space station. And the crew, I want to spend a little bit of time talking about on this. On the left, that was me when I was younger with a mustache that wasn't gray. And space shuttle crews were made up of a couple different types of astronauts. There were pilot astronauts and mission specialists. There were 2 pilot astronauts on the flight, myself as a commander, and then my pilot, Rick Husband. Sadly, Rick was the commander of the Columbia mission where we lost the crew and the vehicle. Great guy. Our backgrounds were very similar. And the way we got to NASA was we were military fighter pilots. Rick flew the F-15 Eagle in the Air Force. I flew the F-14 Tomcat in the Navy. We both went to test pilot schools. Rick, the Air Force Test Pilot School at Edwards Air Force Base. Me, the Navy's Test Pilot School at Patuxent River in Maryland. Excuse me. And so because the space shuttle, we manually pilot it, particularly for the landing phase and the docking phase. NASA always hired test pilots to do that piece. But the majority of the work that astronauts do is not just the piloting of the space shuttle. It's all the assembly on space station. It's the spacewalks. Any ideas why 2 of the astronauts are in white suits and the rest of us are in orange suits? Yes. That's exactly right. Those are the ones that do the spacewalks. So their spacesuits are designed that they can go outside for up to 8 hours, and the suit provides them with, the oxygen, the pressurization, the cooling, the heating that they need to stay comfortable when they're out there. And so on this mission, 2 of our mission specialists did spacewalks, and then the 3 in the middle, we have a flight engineer role, and in the middle is Ellen Ochoa, who did that. She's a mechanical engineer out of California, out of San Diego, but San Diego State PhD mechanical engineer. Up to the left of her is Julie Payette, a French-Canadian astronaut, because the International Space Station truly is international. 5 partners in that U.S. leading role, Russia also a leading role. The European Space Agency, 17 countries in Europe contribute to that. And then we have Japan and Canada. So anyway, Julie, a Canadian astronaut. Next to her is a really interesting story. When I first joined the Navy, the Soviet Union existed. I spent a huge amount of time, energy, understanding what a Soviet fighter pilot was like, because we assumed that if we wound up in a conflict, it would be against the Soviets. So the truth is, I knew more about the Soviet Union ships. I knew a huge amount about their fighter airplanes and spent a lot of time learning that. This guy was a Soviet fighter pilot, Valery. Same thing. He figured if there was ever a conflict, he'd be trying to shoot me down and I'd be trying to shoot him down. So 2 of us that grew up training how to shoot each other down became crewmates. His first flight in space as an astronaut was on this crew, and we're friends for life. It's kind of really neat, particularly in aviation and space. We all have the same passion. And what I learned from being around a lot of our international partners are, people are all alike. Cultures are a little bit different, but when you get down to it, people are alike. The Russians are very, very warm and family-oriented. So, with Valery, I've got a great friend for life. The spacewalker on the left, Dan Barry, medical doctor, electrical engineer, a couple of degrees, huge kid. I came up with this theory. As a pilot astronaut, I had a master's degree in aeronautical engineering, but the majority of the mission specialists had more education with doctorate degrees. And what I determined was the more education they have, the bigger kids they became when they got onto orbit. They loved to play. And then on the right, Tammy Jernigan, kind of a neat story, a volleyball player in college, Princeton and then Stanford, but also a PhD in astrophysics. And when we landed, she had more time in the space shuttle than anybody on Earth. It was her 5th flight. And she was also the youngest astronaut ever selected when she was 26 years old, and finished her degree at Rice University when she started the astronaut training. But hopefully that gives you an idea of what the crews are like. I loved being a part of that team. Here's a picture of Valery. And so I was the commander of this mission, so the boss. And mission commander kind of implies you don't fly, but the truth is the mission commander does the majority of the piloting of the vehicle, and the pilot is really the co-pilot. But after we had docked with station and we were aboard, we were filling out a log, and I looked over at Valery and noticed, for now about the 5th day in a row, every time I put on a shirt, I looked at Valery, his shirt matched mine. And the way it works at NASA, they give you a Lands End catalog or a J. Crew catalog, and you go pick out a polo shirt for each day, and that's the last you know, and you get on orbit and you pull a shirt out of the drawer and you're off and running. And rarely do your shirts match. But I looked at Valery one day and said, "Nice shirt." And by the way, my Russian wasn't very good, nor was his English. But Julie Payette spoke 7 languages, fortunately 2 of them English and Russian, so we had an interpreter. And Valery, in his English, said, "Me shirt, you shirt." And he had gone and gotten my list of shirts that I filled out and turned in, and just said, "Duplicate the commander shirts," right? I want to show the commander that I support him. And so kind of a tribute to internationals. On my next flight, too, I had a Russian cosmonaut, same thing. He was absolutely loyal and wonderful to have on a crew. So my 5th flight was again up to space station, but this time there was a crew on board. And so since there was a crew, it was kind of a different dynamic going to somebody else's place. On the space shuttle, we had 7 astronauts on board. At this time, the space station was small enough that it only had a crew of 3. And when we set all the rules and made the regulations, made the laws, right? What kind of governing laws do you have in space on the International Space Station? One of the laws was when the shuttle docks, if things go awry, the shuttle commander is in charge of the entire stack. And so on this one, when we docked, I started thinking about that. There's 3 long-term astronauts, cosmonauts. And by the way, they all have way more time in space than I do because they've been on board for 4 months. On the space shuttle, we fly for a couple of weeks at a time. And the commander was the first Russian commander of the space station, Yuri Yusachev. And I kind of casually knew Yuri, but not a lot. So I spent some time thinking about, hey, when we show up and we dock, we need to be able to work as a crew of 10, not a shuttle crew of 7 and a station crew of 3. And so I kept thinking about this a lot, and I'll tell you what I did in a minute. But when you look at attributes, and when I was at NASA, and actually through my military career, I started really appreciating teamwork. And trust me, when I was in high school and when I was in college, when I was where the vast majority of you are, I had no appreciation whatsoever. I actually kind of thought, naively so, that if I do well in school and I just perform well, then everything will always work out great, and that's really what matters. And I was so wrong. You know, it was so short-sighted. And when I started working as a fighter pilot, and you always need mutual support, and in the movie Top Gun, you know, Maverick's backseaters tend to tell him, "Don't do a Maverick, do not leave your wingman," right? I mean, so you really learn how important teamwork is, and that you can die if you don't have good teamwork, but even if it's not a life and death situation, you are so much more formidable as a good team than as a bunch of individuals. And we see that in sports all the time. So teamwork is really important, and one of the fundamentals to good teamwork is people skills. Followership. Has anybody ever heard of National Outdoor Leadership School, NOLS? Anybody? So yeah, a few have. I really hadn't when I was at NASA. And some folks had, and as we try to develop crews, because you know we'll grab, you know, from this cruise, you see we have people from all different backgrounds, all different walks of life. We pull them together. 8 months later, we expect them to execute things really well, because if they mess something up, it can be a bad day, you know, literally the end of the day for them or a space vehicle. And so we put a lot of effort into how do we work on teamwork. In National Outdoor Leadership School, we started talking to those folks based out of Lander, Wyoming, and they created courses for us with instructors. And as a matter of fact, when I became the head of the astronaut office, I took my staff. The first thing I did as the chief was I took my staff, so 9 of us went through a NOLS course. They're a week and a half long. They actually like you there for 2 weeks. We backed them down to 9 days. They go different places. We happened to go into southern Utah, into the Canyonlands, on an expedition for 9 days where water was a challenge. You get put in stressful situations that you haven't been in. And the 9 of us, we rotated who was the leader each day. And you started seeing in real life how leadership mattered, more importantly, how followership mattered. And I'd never even heard of the definition followership. But for the most part, when you're on a team, there's one leader, and all the rest are followers. So you really learn to be a good follower. It was really important, and I learned so much. And actually in the Knolls, I learned a huge amount about myself. And I learned a huge amount too, watching other folks and looking at their strengths. And in some cases, they're the other side of their strengths, their weaknesses, and trying to figure out, okay, here's how I can be a better teammate. Earlier, I'd mentioned my mother's an English teacher, but communication skills. You know, as soon as I was a Navy fighter pilot, when I became a test pilot, when you do something, you need to be able to document it and communicate it. So as a test pilot, a lot of times after flights we get back, you write a technical report. At the end of the whole project, it's a pretty exhaustive report, but you have to be able to communicate. And then typically you'll be at a symposium or somewhere trying to explain it to a group. And so the verbal communication skills are important as well. And then to be an astronaut, technical education. You've got to have math and science. Other than having math and science in your technical education, it doesn't matter what you studied. So we hired educators, so teachers, scientists, engineers, doctors, Navy SEALs, Army veterinarians. As long as you've got math and science in your background, you've met the minimum requirements to be an astronaut. So here was that crew on this flight, and here's another picture of the space shuttle in the, oh no, actually that's my next slide coming up. So in 2001, this mission now, we delivered a robotic arm designed and built in Canada. It was Canada's contribution to space station. So it was about $1 billion robotic arm. We carried it up on the shuttle, and you can't really tell, but here in the forward part of the shuttle, that's a pallet with this robotic arm folded up and hinged because it's 60 feet long, and it had to be folded up and hinged for us to get it up to the station. And in the back was a module out of Italy, an Italian-built logistics module that we attached to space station. The flight went well. The teamwork really turned out to be a great thing. And when we left, here was that robotic arm hanging off of the space station, you can see. So it took several spacewalks by the two spacewalkers and a lot of work, and it was really rewarding. And part of the reason it was rewarding as it was just getting to work with that international crew. Yuri was the commander. We did have some challenges on the flight. When the ground uploaded the new software to drive that arm in more than just a basic mode, it turns out it had a flaw in it, and it caused the major set of computers, we call them multiplexers, demultiplexers, MDMs, the critical ones all failed. And they had disks in them, and the software actually drove the disks with the brakes on, and they failed. Station was crippled. Couldn't talk to anything, couldn't undock the shuttle, couldn't remove our logistics module, couldn't move the arm. The good news was, on the space shuttle, we could still go into it and communicate back with the ground. And so the folks in Houston started trying to figure out, okay, what do we do? And typically what you do is nothing, right? Don't make it worse. There's a saying, there's no situation so bad that you can't flip a switch and make it worse, when I was at NASA. So you do nothing for a little while, which a lot of times can be really hard, not to want to jump in and save the day. And trust me, in all of our simulators, I quickly learned jumping in and saving the day was never the right thing to do. For the most part, it resulted in going backwards. So the ground starts figuring things out. And what they eventually had us do was cannibalize these MDMs that weren't in the critical path, put them in the critical path places. In the meantime, they re-uploaded the old software, the basic software, and then went through the new load. And before they sent another new load up, by the way, the shuttle was long gone, then it worked. But we had to work together as a crew of 10. So the whole philosophy that I had embraced before we launched, I thought paid good dividends. What I want to do now is change gears. And because one of the things that's really different from living in space is we're floating. Everything floats. So you can't drink fluids out of a cup like this, like you can here on Earth. If we were in space, first of all, this would be floating around. And the water would probably still be in here as long as it hadn't been bumped. because of the surface adhesion. But if you turn it upside down to pour it and drink, it wouldn't. It would just stay in the cup. Fortunately, on Earth, it works a little different. So we have drink bags. And here you see Al, by the way, a chemical engineer. I know we have some chemists in the crowd. He was also a pretty big kid on orbit, loved playing with his food. And so, as a matter of fact, it was his first flight. My first flight and Al's first flight were together. We got on orbit, and you know, you are kind of a kid because it's so different. And he would squeeze the fluid out of his bag. This happens to be a red tropical punch. And the first time he did it, or early on, he squeezed out a lot, I mean, almost baseball size sphere. And when he went to drink it, he didn't get his lips all the way around it. And so what happens, because of surface adhesion properties, it rolled up into his eye socket, right? It would, so Al's there, and I had to go get a towel and kind of save the day for him. Another time, though, same thing. He had a smaller sphere, and he would let it float, and at the right time, drink it out of the air. I came ripping through there, doing real work instead of playing with my food, and didn't see it, and it got on my shirt, and it ruined that shirt. It was actually a striped rugby shirt like this, except blue and white, and that red tropical punch never did come out. Exercising is important. When you're floating, you know, your muscles just don't get used. Your skeletal frame doesn't get loaded like it does here on Earth. So if anybody's ever had like an arm or a leg immobilized because of a problem or a fracture, you know when you get out of that cast that it takes a while. You're a lot weaker. It's kind of surprising how weak you are. Same in space. Even with a couple of weeks, you weaken very quickly. So we're required to exercise, and it doesn't look like it, but that's actually a stationary bicycle that Katie's on. And we had flight rules that said, particularly for the pilots who have to be conscious and fit flying home as we come back into the G field, we had to exercise every other day. And I ramped that up. On my second flight, okay, here's one more story. On my second flight, we went up. We were supposed to do a spacewalk, and the hatch was jammed. We couldn't get the hatch open. So what did we do? Nothing. The ground says, give us a day to figure it out. So for me, it was a beautiful thing. I had a day without being scheduled, you know, from the minute I got up until I went to bed. And so I thought, you know what? I'm going to cycle around the world. How many people have cycled around the world? Yeah, that's exactly why I'm going, hey, I could do something that a lot of people haven't done. I'm going to cycle around the world. Does anybody know how long it takes to cycle around the world when you're on the space shuttle? Hour and a half. So that's exactly right. So I set my stopwatch at 90 minutes. I jumped on the stationary bike, and I was flying with, at the time, the oldest human to ever fly in space, Story Musgrave. Excuse me. His sixth flight. And when I jumped on the bike, he was up on the flight deck, and he says, my call sign is Rommel. I got that as a fighter pilot just because my last name's German, or everybody thought I flew like a tank driver. So he said, Rommel, you have to come back to the same continent. I was like, duh, right, yeah. And I said, okay, where are we? He said, we're over India. I go, great. So I start pedaling away. And I started off easy and then started turning up the resistance on the stationary bike as the clock was winding down. And so the last 20 minutes, I crank it up, and I'm sweating like crazy. Now, in space, if you sweat like crazy, you always need to have a towel, very handy. Because if you shake your head like that, and you are not popular, you are not being a good teammate when you do that. And your other teammates will let you know about it. And hopefully you won't be bloody after they let you know about it. So anyway, I had a towel. The last 10 minutes, I cranked this thing up, and I was dying. I was just really, I was totally wet. I'd been riding so hard because it is not easy riding around the world. And my timer goes off after 90 minutes because it takes exactly 90 minutes to do a complete orbit. And the clock goes off, and before I stopped, I yelled up to Story and said, hey, Story, where are we? And I was fully expecting him to say India. He says, Libya. I went, Libya? Don't you mean the other country that ends in an IA? India? He said, no, Rommel, it's Libya. I was like, crap, and I'm doing the math in our inclination and going, we're probably 6-7 minutes away from India. So I continued I did not have a cardiac arrest. And finally Story said, okay, we're over India. And I stopped. And it took me like 98 minutes. Does anybody know why? Because obviously at the time I didn't. Yes. That's exactly right. So I did a complete orbit, which takes, at the elevations we are, exactly 90 minutes, or the altitudes and the speed, in space. So for 90 minutes, I was going right back to that place where I started riding that bicycle in inertial space, say relative to the sun. But the Earth was rotating under us. And so Story knew this, right? Mission specialist, he had a bunch of degrees. And he also knew I didn't know it. But in the end, he saved me. And by the way, I was not the first astronaut to claim that I'd ridden around the world. So when I came back to the office, I went up to another pilot who had mentioned in his debrief, hey, he cycled around the world. So I thought, hey, that's pretty cool. And I went up and asked him, I said, hey, Rick, how long did you ride? How long did it take you to get around the world? He said, 90 minutes. I said, oh. You were a little short. I felt kind of bad telling him. I think he still goes with he cycled around the world. And I'm like, hey, you almost cycled around the world. So on Space Station, we just got Scott Kelly back. He'd been up there for over a year. Actually, I lied, just under a year, 340 days, a year. And guess what? We do not have a shower or a bath on Space Station. Neither did the space shuttle. So you take sponge baths, and you have a little hygiene water hose, and you have a washcloth, and you have soap and shampoo. And that's pretty much it. And the good news is, so it's kind of like going on a camping trip. And before I launched on my first flight, I thought, I wonder if you can really get all that clean with doing a sponge bath. And more importantly, because we're all working out, can my crewmates get clean as you're doing this with a sponge bath? And you can. The good news is, I tell you what, I always felt just like getting out of the shower here at home, really clean, refreshed, and just great after a sponge bath. This is one of the crewmates washing his hair. Sleeping. Sleeping is really different in space. And I hadn't really thought about this either. But on Earth, when we go to bed at night, it's kind of things change because you lie down and you can completely relax, right? You don't have to, you can just totally relax. And even in a chair, right? I've proved many times I can fall asleep in a chair by relaxing. In space, when you're up and about, you can just close your eyes and totally relax anytime, anywhere. That's the good news. The bad news is when you go to bed and it's time to go to sleep and your brain needs to say, hey, it's time to go to sleep, there's nothing different other than you closed your eyes. So particularly the rookie astronauts have a hard time sleeping in space, so we fly sleep medication, and pretty much everybody has to use it at least the first couple nights to get to sleep. After a while, you kind of train yourself, but it is very different just falling asleep in space. And then we have these little bags, kind of look like sleeping bags, but they have 4 straps and you tie them off. And I thought, well, shoot, why tie it off? I'm in space. But the reason you tie it off is the air currents will cause you to kind of float around, and you'll bump into something or somebody throughout the night and kind of become a little bumper ball. So you actually do want to tie it off. It can be to the ceiling, the wall, the floor. It just doesn't matter. Photos. Hey, so now what I want to do is try to share with you, hey, this planet we live on is gorgeous, phenomenally gorgeous. And so, we're with Orbital ATK, we're one of the 4 prime contractors helping NASA build a mega rocket that will get us humans to Mars. And Mars and the moon, I would absolutely love to go to those. And then when I get asked the question, hey, would you go one way to Mars, because there are folks out there going, hey, let's go one way. It's really hard to get back from Mars. It's way easier just to go and land there, but not have the capability to get back off of Mars and get back home. And the idea being you go there and you figure out how to live off the land and you stay there forever. And they posed to me, hey, if you could take your family, would you go to Mars and live there? And I was like, absolutely not, right? I mean, the Earth is a gorgeous place. There's so much we can do. It's not a hostile environment. Mars is monolithic, pretty much, right? It's reds and browns, period. Good news is you weigh less. You only weigh 3/8 of what you'll weigh here. But no. Would I go there round trip to the surface and visit for, a yearish time? Absolutely, I would love to. But not one way. And, when you look at our solar system, there is nothing in the solar system like our planet Earth. And that becomes very, very apparent when you're able to fly in space and look back down on the Earth. So when you look at the Earth from where the space station is or the space shuttle is, it looks kind of like this. This is the right perspective where you can see the curvature of the Earth, but by no means is it as if you're on or near the moon and you look back and it's a ball that big that you can cover up with your thumb by holding it out in front of your eye. But we flew a lot of telephoto lenses and took thousands and thousands of photos on the missions. And so this is actually Mount Everest in the middle of this with a telephoto lens. And growing up in the Rockies, I was really excited to see the Rockies from space. Turns out I saw the Himalayas first, and then when we came over the Rockies, I was kind of disappointed. They weren't as exciting as I thought they were going to be. The waters, 2/3 of the planet's water, the most gorgeous waters on the planet are south of the U.S. So the Bahamas, kind of all the way in through the Gulf. This happens to be Grand Cayman Island. They're just really gorgeous. The picture doesn't do it justice. But you can see as the water shallows and there are coral reefs, the turquoise and blues that you see are really, really pretty. Hurricanes. Coincidentally, 4 of my 5 missions, there were hurricanes on the planet. And they're huge. They have a very defined eye. So they would easily, they're so big they easily would cover the entire state of Utah. And even when I lived in Texas, I had to tell all the Texans, hey, I'd even cover your state, our state at the time, because it's so big. But pretty fascinating to see this geography lesson from space. Does anybody know how fast the space shuttle goes? So we're going over 17,000 miles an hour. And to put that in perspective, that's about 5 miles per second, which is fast. Fast enough? Nope, but it's fast. Okay, so now this is a quiz, part of this lecture. Does anybody know what this island is? Maui, very good. Okay, here's the next question then. Do you know why it's red?
That's what color foliage looks in the lenses, isn't it?
Yes, so you're on to, this was an IR sensitive film. So it looks at heat, and particularly in the mid-90s when I was flying, we were doing a lot looking at deforestation around the planet, so a lot of stuff out of South America we would take. And the different films that we would fly would show where vegetation was healthy, where it wasn't, where things were hotter than other things. You can see what clouds look like as well. Okay, here's a tough one. Where is this? Okay, I heard the answer. So the Red Sea. This is the Nile. And then the Nile Delta right here. Cairo, Egypt happens to be right there. And along the Nile, with the telephoto lenses you were looking through, you could actually see the pyramids. So it was pretty cool to see the Nile. But you had to be quick, right? At 5 miles per second. You only had a nadir, a direct down view for a pretty limited amount of time. But you can see it's fascinating. Now, is anybody here from Missouri? Okay, so I was trying to shoot a hometown for a guy in Eminence, Missouri, and there's no way in the world I was ever going to find that town. Because it's not like you had a border between a lake and a sea or a big river. So in the Midwest, it's just really tough. Salt Lake City, You can see Salt Lake City. Now, the one thing, and there have been books, Michael Collins, I think, in his book said, hey, from space, you can see no borders. You know, as an engineer, I kind of always, well, but you really can, right? Because coastlines a lot of times are borders, rivers. But Michael was really implying that, hey, land-to-land borders, you really don't necessarily see them. But can folks see this line here? So this is an exception to that. And as a matter of fact, this is Israel, and this is Egypt. So there really clearly is a border. And it's what they do and how they cultivate their soil, what they do differently between the two nations. So I thought that was always pretty fascinating. Okay, where is this? Lake Powell. Yeah, so Lake Powell is just gorgeous from space. It's actually gorgeous when you're on the lake. Lake Powell is one of my favorite places. Okay, what about this? The Great Salt Lake. Hey, does anybody know why it's two different colors? It's kind of a brownish red on the northern end and more of a blue over here. You're right. So there's a railroad trestle that kind of actually separates it into a couple of bodies of water. But why are they different colors? So that probably is part of it. I'm going to tell you what the NASA scientists told me, because I had no idea. They said in the northern part, it's a combination of brine shrimp and algae. And probably both of those are a direct result of the fresh water either not coming into there or coming into there. It's probably not coming into there, right, because the Jordan River comes in down here. But the Promontory Point, you can see, really stands out. And Antelope Island. And this is hard for me to see from the podium, but I like to point out where we are. I think we're about right there. There's another phenomenon you get to see from space. And what is that? Right, so I heard aurora, I heard borealis, northern lights. So it's actually, it is an aurora, but for those of you that said northern lights or borealis, how do you know it isn't the southern lights? Or australis? Yeah, so I've seen them both. I don't know how you would tell. This happens actually to be the southern lights. And so, but it was really a neat experience. We were above it most of this flight. This was on my third flight. And late in the mission, we dropped to 110 miles. We were up around 200 miles above the Earth. We dropped down to 110 for a certain experiment and went right through it. And we actually disturbed it and caused it to wave. And I remember kind of thinking, I'm not sure we should be doing this, going through this. And was keeping an eye on the computers on the space shuttle, which our lives depend on, seeing if they were going to get disturbed, and they didn't. Everything was fine. But then here we are back landing, and the space shuttle, again, I kind of alluded to it some, is a phenomenal machine. It's a rocket, it's a spaceship, and then it's a glider. And here it's gliding. My first landing in it, first time I ever got to land it was at night back in Florida. Loved it. It was a lot of fun to do. So now we're going to transition to a short video clip. So this is my fourth mission. We launched right at sunrise. Beautiful day. We're quarantined for a week before we launch. as soon as we get on orbit, particularly the highly educated astronauts go right to work. Okay, now I'll show you the home video from the entry side of it, which is very unique. Let's see. Does anybody see my cursor? There we go. Okay, so I was a little slow getting it stopped. But did everybody see the light flashing that was on there? That was looking out the overhead window, like the sunroof on your car, and that's the plasma. So it's literally kind of forming into a sphere and what appears to be exploding and flashing. So at night, it's like you have this angry, violent fire above your head, flashing in through the windows overhead. And it's really kind of eerie, an eerie sense. Now we're looking out the windows. So this is actually me in the commander seat. That's the window, and you can see the mango orange color. It's kind of like looking into a fire through the glass on a fireplace. But what's interesting is when the space shuttle lifts off, we weigh about 4.5 million pounds, and 4 million pounds of that 4.5 million pounds is fuel. And that fuel is what we need to accelerate us to 17,600 miles an hour. Now, to come home, we have little rockets on board that we fire, and we slow down just 200 miles an hour, so we're still going 17,400 miles an hour. But that changes our trajectory such that we settle into the atmosphere. And in fact, it's the atmosphere and the thermal protection system on the space shuttle that takes all that energy back out of the system. So it's really pretty risky, right? You're putting a huge amount of energy into the thermal protection system on the space shuttle, hence the plasma. And so that slows us all the way down to 300 knots until we're on our final approach coming into the runway. So here we are looking around the crew. That happens to be Jeff Ashby, who worked for us at ATK for a while. Berto Godoni, the Italian astronaut on board. And now we're slow. And unlike an airliner, we're a glider. So we're coming down a glide path that's 20 degrees steep. Airliners typically on about a 3-degree glide path. And so this is like flying a bombing run in a military airplane, and except for dropping your bombs and pulling out, you drop the landing gear and land. So we trained a lot. It's actually a lot of fun flying this profile. But we do touch down fast, quite a bit faster than an airliner. An airliner will touch down typically around 130, 140 knots. We're up around 200. So we have a parachute, a drag chute we call it, that helps us slow down. So as it's rolling out, okay, so with that, I was a little longer winded than I intended to be, but we've got a good 5+ minutes for questions. Who's got a question they'd like to ask me? Right here.
First of all, sir, thank you very much for your service, sir. Secondly, kind of at what point in your career did you see yourself going that path?
Right. So the question was, hey, my experience as a test pilot, what airplanes did I fly? And then secondly, out of everything, what really prepared me for becoming an astronaut? Excuse me. Getting over this nagging cold. So as a test pilot, the 35 airplanes, I spent most of the time in the Tomcat, but flew the F-18 a fair amount. The A-7, we used it for certifying landing systems on aircraft carriers. I'd go out to aircraft carriers when they would get reconditioned or brand new coming out of the yards. We'd be the first ones to certify their equipment. But got exposed to pretty much most of the airplanes in our inventory. I did, for a final project, get to go to France and was one of the early guys to get to fly the Mirage 2000, which was kind of France's F-16, fly-by-wire 9G airframe at the time. Loved flying it. got to fly big transports, flew helicopters, flew several different helicopters. And so the idea being as a test pilot, expose us to everything that's kind of out there. And that way, when we're developing new airplanes, leverage, don't repeat history, leverage the good things you see in those systems. And actually, really what prepared me, I think, for going to NASA was when I got into Miramar flying the F-14s. I'd been there about a year, and a test pilot from the Navy's test center came and gave us a presentation. And he explained to us that if you want to be an astronaut, a pilot astronaut, you need a test pilot degree. And that's when I decided, hey, I think I do. I think that's what I want to do. So having that presentation prepared me. And in the Navy, I applied for a test pilot school. They also had a cooperative agreement with the Navy's graduate school. So you could go to graduate school for a year. And then out of graduate school, you rolled into the test center. Test pilot school was a year. And those 2 years of education culminated into a master's in aeronautical engineering. So hopefully that answered your question. Yes? What food did I miss? Hey, so first of all, what I learned on my first flight was they give you this menu with like hundreds of choices for food. You'd fill it out. The dietitians would look at it and come back and say, no, you need more manganese. I always needed more manganese in my diet. I don't even know what manganese was in, but so they go, no, you need more of this and more of that. I said, well, do I have to eat it if I fly it? And they're like, nope, but you have to fly it. So I'm like, okay. So I changed the menu. And it's a lot of work picking out 18 days worth of food. So I decided, you know what? I'll pick out 3 days, and then I'll just repeat it. Big mistake. Never do that. I got so sick of eating the same food all the time. But to answer your question, shrimp cocktail I loved, and NASA's food lab did it and irradiated it. So you added water into it and squished it around, and it was actually pretty good. We also flew military rations to eat, the same thing our troops eat, the MREs. And I liked the beefsteak from the MREs. One of the real treats when we went to station was the Russian food. And so borscht, right? The first time I heard about borscht, I thought, I don't think I want borscht. It just doesn't sound good. I tasted the borscht. It was delicious, right? I had no idea beet soup could taste good like that. It was really, really good. And what I found I craved was a variety. So back on Earth, when I got back on Earth, the fresh fruits, the breads, the things you just don't have in space, I really appreciated when I got back. Yes? Do I have any regrets? I do and I don't. One of the big regrets is when I became the head of the astronaut office, the first mission that launched on my watch was Columbia. And so obviously 7 very close people. Rick Husband, the commander, was very, very close to me. When that happened, it was a nightmare come true. I always tell people, for the most part, my timing has always been good. That was one where I stepped in this job and it just was a nightmare, right? And so for a couple of years in the astronaut office, we had to figure out, hey, what are we doing to get back on our feet? What do we need to do to make sure this never happens again? The fact is, I've always regretted that somehow I wasn't able to prevent or be a part of the system that could have prevented losing that crew. The flip side is you always have to look forward. I feel really good about everything we did and put into place after Columbia. And so we did not lose another shuttle and crew after that. So great question. Yes?
I was wondering, how does being in outer space affect your sense of smell, your taste, hearing, and seeing, and also use like your blood flow, your digestive system, and all that?
Yeah, so we could talk for about 3 hours. The question was, being in space, how does it affect your digestive system, your eyesight, your smell, your taste, your hearing? I'll focus in on a couple of them. The couple of obvious ones are, as soon as you're in space, once your muscles atrophy very quickly, but also your skeletal system, your body says, you know what? You're not you're not using these bones. You're floating around, dragging all this mass of bone, and near as I can tell, you don't even need near this much bone. So your body starts getting rid of bone mass, because you're not using it. And so it starts getting rid of bone mass. As a result, we have exercises, particularly on station, that are effectively resistance training, weightlifting. When running on a treadmill is really good. On Earth, the docs tell you, hey, they used to tell me, you should ride a bike instead of jogging, right? Because jogging's hard on your knees. It's just the opposite in space. In space, you want to run on a treadmill, you have a bungee system that holds you from your shoulders down, and you want to jar your body on space, right? You want to bounce, because loading that bone, even momentarily, that jolt going up through it, signals to your body, hey, stop getting rid of bone mass. So losing bone mass has always been a challenge, and NASA's devised different techniques, protocols to minimize it. So we do pretty good in most of the areas. There are certain areas in the pelvis that we don't. The other thing that immediately comes apparent when you get on orbit, you puff up, because all the fluid in your body that is used to being held down by gravity is no longer. So it floats up. And physiologically, our bodies don't need nearly the amount of blood volume in space that they do here on Earth with the effects of gravity that we have here. So when the first day or so on orbit, you urinate like crazy. It's just astounding, right? And well, the end result of that is the blood volume in your body drops probably a liter or so, because your body just doesn't need it. And your puffiness then comes back down to somewhat more normal. Now, so before we come home, we have to take salt tablets and fluid load. Like for my case, I think it was 40 ounces. Right before entry, pop a couple salt tablets, choke down 40 ounces of water. Kind of one of the miserable things you have to do. But if you don't, you can become faint. You can actually pass out because you just don't have the fluid in your body. And as you re-enter the G field, it can cause that. Eyesight is a challenge with the long-duration astronauts. The shape of the cornea changes because of the effects of gravity. And I'm nearsighted. I think if you're nearsighted, it helps your vision. If you're farsighted, it doesn't help your vision. And so eyesight changes on orbit as a result of that. So anyway, but after the fact, I can grab you. I think, are we out of time? Whenever I'm ready? 5 more minutes. Okay, I talked him into 5 more minutes right here.
Where's NASA going with the equipment-wise in outer space exploration? I know that our government has cut back on funding for various different reasons. Do you see any upcoming future missions that will not be, testing what it's like to be in space, but to advance our technology and civilization?
Yes. So the question is, hey, where's NASA going? Well, I know there have been budget cuts. Do you see any missions coming up that will advance technology and civilization? And the exciting news is yes, right? When this current administration came into office, they canceled the previous administration's plans for NASA. And NASA had an Ares 1 and an Ares 5 vehicle. Ares 1 was for the crew. Ares 5 was a big mega rocket. They canceled it. Go thank your congressman. House, Senate, Democrat, Republican, all alike came together and said, hey, you know what, administration, you can cancel the small rocket. We believe you need heavy lift to ever get humans back to the moon and onto Mars. So go figure it out. Use parts of, by the way, we'd spent $9 billion as a country by then into developing the Ares 1 and Ares 5. Congress told the administration to tell NASA, hey, go figure out how to salvage everything from Ares 5 that you can. And they did. And they designed, it's called SLS, Space Launch System. But it'll put in between 200,000 and 300,000 pounds of mass into orbit, which is huge. But that's what you need to do to put together a campaign to take humans to Mars. And if you saw The Martian, right, that's a pretty big ship that the crew translated on. But that's only a piece of it, right? You need all the fuel, you need all the food, you need all the supplies, you need a lander to take you down to the surface, and then you need an ascent vehicle to bring you up off the surface, and you need a habitat on the surface. So it is pretty complicated, but absolutely, yes, that's where we're headed. That's where NASA's headed. So it's really exciting. The first flight of this mega rocket is in 2018. I'm proud to say the solid rocket boosters on it, they're a bigger version of what was on the space shuttle, are coming out of Utah here. So we in Utah are a big part of it, but it's really exciting. At the same time, NASA is reaching out to what we call commercial companies to do the low Earth orbit stuff. So you'll hear the name SpaceX. The one you don't hear so much is Orbital ATK, but both Orbital ATK and SpaceX have contracts to take logistics up to space station right now and resupply the crews. So anyway, way in the back.
Yeah, in the future decades, would they expand the number of people in orbit? I was wondering if you would adopt an Earth-side rule that fire departments use called the two in, two out rule. Two in, in the case of the fire departments, is two people do the quick search for the rescue. Two people outside are on standby doing nothing but waiting for something to go wrong. I'm wondering if in orbit EVA rescues might be something similar. Two out doing the EVA rescue, two in their pressure suits and sealed, ready to go. The primary EVA pack, a handheld thruster as a backup, maybe one or two EVA lines as a backup to that. Some kind of future protocol.
Yeah, so the question was, have we ever thought about as we get to larger crews on station, two in, two out, when you're doing spacewalks, which are hazardous. Statistically, there's like a 1 in 400 chance that it's going to be a bad day. A piece of debris is big enough to penetrate your suit and you. You know, that's a really good idea. I don't know that we've thought that far ahead. And the reality of it is, I think for the next couple of decades, the crew sizes are probably such you don't have a luxury of a 6-person crew having 2 outside, 2 on standby, which leaves only 2 to really do all the work on the spaceship inside. But it actually makes a lot of sense. Maybe there's a hybrid version of that where you have the suits and everything ready to go, or some people can sprint, jump in their suits and try to get out the door. So I think I've got time for one more question. This was the first hand. Yeah, so the question was, as a result of us losing Columbia and before that Challenger, before that the Apollo 1 crew, how do you deal with when you launch in space knowing that, hey, you may not come back, you may not get to see the Earth again or your family again? And it's something, particularly after we lost Columbia, we hired another class of astronauts in 2004. We lost Columbia in 2003. We hired a class in 2004, and as one of the guys kind of leading that selection board, we worked really hard with the candidates that we interviewed to say, please, go back, talk to your families, please understand your chances of dying when you climb on an airliner are something like 1 in a couple 100,000. You in the military, your chances of dying when you fly your fighter. When I flew my F-14 up over Iraq during the Desert Storm conflict, my odds of dying on that particular flight were 1 in 20,000. When you climb on the space shuttle, history has shown us your odds of dying are not even as good as 1 in 100. So orders of magnitude more hazardous jumping on a spaceship to date, space shuttle, and not coming back. So that's something we asked people to deal with. What I saw were the astronauts themselves were able to deal with that pretty well. What was the biggest challenge were the families. And one example is as a chief, I went to one of our astronauts and said, hey, look, here's a flight, great flight. I'd love you to be on it, fly this position. And that astronaut said, I can't, right? I have young children. One of them was close to one of the crew members that was on Columbia. And anytime I mentioned flying, it just totally unnerves this child, tears, tantrums. So it's the family, too, that you have to really take into account. They have to be willing to deal with it. So my daughter, after we lost Columbia at the time, was 10. And so as we're working back through this, I asked her one day, we're driving, my wife and my daughter, I said, hey, so honey, what do you think? what would you think if I told you I was going to go fly the space shuttle again? She said, well, Dad, don't fly on the first one. If it doesn't blow up, then go for it. So I thought, okay, that's pretty good logic out of a 10-year-old. But anyway, hey, thank you so much. You've been a wonderful group. Really enjoyed talking with you.